How do we graph and use the conic section of parabolas? Well, parabolas are a conic section. They can be cut out of a cone. And the definition of a parabola is the set of all points equidistant from a focus in a directrix. So this is formed by all of these points on the parabola being equidistant from a focus in a directrix, the closest point being this vertex. The standard form of a parabola can be written in two ways. A vertical parabola, or the parabola that most people are used to seeing, is x minus h squared equals 4py minus k. A horizontal, the y is squared instead of the x. Notice that there's only one squared term, unlike the rest of the conic sections. And this is written differently than we've probably seen parabolas in the past. Just like the center of the rest of the conic sections, a parabola's vertex is at hk. Now P gives us the distance from the focus to the vertex, so from here to here, or the distance from the directrix to the vertex, since by definition these have to be the same length. Now because this has a vertex at hk, then we know that the focus will just be at h, comma, k plus p for a vertical parabola. For horizontal, it'll be added to the x, so h plus p, comma, k. The directrix just goes the opposite way. This is y equals k minus p, or x equals h minus p. That's just because a horizontal parabola, if you haven't pictured it in your head already, looks like this. So a vertical parabola is a function and a horizontal parabola is not. For a parabola, there's a line that travels through the focus and it hits both sides of this parabola. And it's called the latus rectum, okay? And its distance is equal to 4p. So that just means that the distance from here to here is 4 times longer than the distance from here to here. Note, my drawing is not to scale. All right, we're going to graph y plus 1 squared equals 8 times x minus 3. Notice that the y is squared, so this will be a horizontal parabola. The vertex is just at hk, so its vertex will be at 3, negative 1. So I'm going to go ahead and graph that at 3, negative 1. And then I need to start thinking about the focus. Okay, so from the standard form, remember that it was, y minus k squared equals 4p x minus h. So I know that 8 is equal to 4p, making p equal to 2. So I'm going to go positive 2 out from the vertex. And because I know it's a horizontal parabola, I know I need to go in this direction, because this parabola is going to open up this way. Now this also lets me know that the directrix must be the equation x equals 1. So at x equals 1, I'm going to draw a vertical dashed line. Now I need a couple more points for this parabola. So knowing that the latus rectum travels through the focus and is equal to 4p, well, 4p is equal to 8, I'm going to go 4 up and 4 down from my focus. Now I've got enough points that I can draw this parabola. When we're looking at the general form, either a has to equal 0 or b has to equal 0. We can only have one squared term for parabolas. And so let's convert this one to standard form. First we notice that x is the term that's squared, so we're going to get just our x's on one side. Now that we have just the x's on one side, we can go ahead and complete the square. So half of 4 is 2. Squared is 4. I'm going to add 4 to both sides. On the left, that's going to reduce to x plus 2 squared. And now on the right, we have negative 8y plus 8. Now the only way for this to work is you have to factor out whatever number is in front of the variable. So this actually is x plus 2 squared equals negative 8 times y minus 1. If we wouldn't have factored out that negative 8, you wouldn't have known that the vertex was at negative 2, positive 1. All right? And so now we've converted that to standard form, and we could go through all the steps to graph again. But for the purposes of the notes, we're not going to. All right, so let's look at a word problem. A satellite dish is to be constructed in the shape of a paraboloid of revolution. That just means you take a parabola, spin it around, and makes a dish. If the receiver placed at the focus is 2 feet above the vertex of the dish. So here's the receiver, here's the vertex. How deep will the dish be? Now we're told that this is 12 units wide, and anytime you have a word problem, it's usually best just to make your vertex 0, 0. Because we know that this is 12 units wide, this side must be 6 units long. So this point right here is 6, comma, we don't know how tall, 6, comma, y. Well, now we actually have enough information to do this problem. This is a vertical parabola, so it's coming from this form. X minus h squared equals 4p y minus k. And we have all these things that we can plug in. The first things that are easy to see to plug in would be like the center, so x minus 0 squared equals 4. Because the focus is 2 away, p is equal to 2, so 4 times 2 times y minus 0. So we have x squared equals 8y. And now to figure out this y value, I can just plug in this x. So 6 squared is equal to 8y. So y will be equal to 36 over 8, or 4.5 feet high. All right, and that is parabolas. Goodbye.